Todd Stringer, and this is R-2000, the Better Built House. Over the course of the series, we've been looking at the importance of controlling air, heat, and moisture flows throughout a structure, and in particular, how those issues affect the design of an energy-efficient house. In the last few programs, we've focused our attention on the foundations and basements in R-2000 houses. They're comfortable and efficient and built with particular care and attention to three things. Here they come.
We've seen how moisture problems in house basements and foundations are reduced by good drainage practices, such as damp proofing and vapor barrier materials. We've shown that carefully installed insulation over the foundation walls, and in some cases, even under the floor slab, will result in improved comfort levels. And finally, how air leakage into and out of the house can be controlled, usually by installing a well-sealed air vapor barrier.
In this program, we're going to look at how those same three principles affect the design and construction of above-grade walls. I'm going to go find Oliver. Hi, Oliver. What's in store for today?
Well, today, David, we're going to look at designing and building walls and at different framing systems and how they go together.
Well, before you get me lost in the maze of 2x4s and 2x6s, what are the key issues?
Well, primarily construction sequencing and costs. You've got to appreciate that it's a lot of aggravation for a builder just to keep it all together when constructing a whole bunch of houses. And anything that's going to make his job more difficult is something he really doesn't want to know about. So we have to ensure that the things that we're trying to accomplish are fairly easy to do. And let's look at what those are. We want to have a higher level of insulation in the walls. Depending on where you are in North America, it could be as high as R40. We want to have a continuous air barrier, and we want to have a continuous vapor barrier. And we want to make sure that those go in the wall as simply as possible.
I guess each builder is going to have different questions to answer in his own way. Is that the way that works?
That's exactly right. What we're looking for is the type of crew that the individual runs, the type of client they have, their location. Take, for example, a bungalow. If you're framing a bungalow double stud construction, it's a very simple proposition. If you're framing a two-story building with bay windows on it, lots of cantilevers, that kind of thing, it could be very difficult.
What kind of system do you prefer?
Well, it's hard to answer because we've done just about all the various systems that are out there. Nonetheless, it depends on all these variables as to which system you'd select.
Well, you're the experienced R-2000 builder. Why can't we just follow you around and do what you do, right?
Well, I think what we ought to do probably is review the types of alternatives available to us. There are essentially 4 different framing techniques, and why don't we go over them one by one?
Conventional wall construction can be improved by either adding insulation to the exterior of the house with an insulating sheathing, or to the interior using a cross-strapping technique. Of course, you can do both at the same time. Alternatively, a secondary wall can be built and located either on the inside or the outside of the main structural wall. This approach is commonly referred to as double wall construction. A third approach, truss wall construction, involves hanging a separate wall outside of the house structural wall using either wall trusses or a similar standoff wall system. More recently, we're seeing the use of prefabricated or factory-manufactured wall systems, which come to the site in full sections with the insulation already in place.
That's an awful lot of options. Where do we start?
Well, we're going to start by looking at upgrading single-stud construction, which is what you see here. This builder has already done some upgrading in that he's gone to 2x6, but I think I can demonstrate this best to you outside.
Okay. Looks like we're finally going to get something I can understand. We're going to play with blocks, right?
Yeah, we certainly are. What I wanted to point out to you is the difference between these various blocks. This is a 2x4, that's a 2x6. Can you guess? It's a 2x8. Now what we're going to find is that most of the framing that takes place in a single stud wall is going to be done with 2x6. You can get a not so bad wall with a 2x4. But you have to really pack the sheathing to it on the outside, or else do something to it on the interior, or else use a very, very expensive insulation material in order to get high R values out of it. So we'll lose that one.
Okay.
2x8s are very expensive in and of themselves, and they're also very heavy. So when you've built a wall out of them, it's extremely difficult to erect without doing damage to your vapor barrier tabs and that kind of thing. So generally speaking, we aren't going to see much of this around. We'll lose that. And what we're left with is the 2x6.
So you're going to go with basic 2x6 wall construction.
That's pretty well the first thing that you can do to expand the wall, is just to expand the stud itself. Now, before we start building a wall, we've got to have a floor. And I just want to point out to you the foam gasket that's sealing the sill down to the foundation. We want to be very certain that we get any of these other cracks between the floor and the header, between the header and the sill also sealed. So we're going to put a piece of poly in there. Comme ça. Now, that's going to go up over the outside of this header and up onto the floor. The difficulty with this is that we've already violated the 1/3, 2/3 rule. We've just taken a membrane and carried it to the outside of our house and back up onto the floor. What we're after is this little tab of poly that's going to be in the inside to connect the main vapor barrier to.
Okay, but in a nutshell, this is a vapor barrier and you don't want to chill it
right
on the outside.
So we're going to have to deal with that before we're finished with this model. Can you hold that up there for me? Here we've got a 2x6, which we'll call a bottom plate. That's going to be sitting right in there. And you're going to wind up with studs that are sitting on top of that wall. That would be an outside stud.
Okay.
Now those studs would, in 2x4 construction, be on 16-inch centers. What we want to do is expand them to 2-foot centers, which leaves us with just as much strength in the wall, but reduces the amount of thermal bridging. And remember, we've still got to deal with this. What you can do, if you want, is use a 2x4 bottom plate instead of a 2x6 bottom plate, and then take the stud and allow it to hang over the exterior of the header. That enables us to go in with an insulative material on the outside to keep that vapor barrier warm, and then still put an insulative sheathing up the outside of the studs.
Well, what kind of sheathings are you going to use? Are you stuck with this rigid board?
Well, it's actually a very, very difficult decision for a builder to make. There are a wide variety of materials on the market. This particular one is extruded polystyrene. There's also an expanded polystyrene. I've got a sample here of a urethane board, which is also used for the same kind of thing. And this one is interesting because it's a fiber. Now the fiber, the choice is really going to be based on what comes on after it. The fiber is obviously somewhat softer than these foams are. But what's important here is the fact that it comes with a Tyvek wrap already on this particular fiber product, which is going to be taped at the joints and give us a really good wind barrier on the outside of the wall as well.
Now that wind barrier is to prevent air moving through not just the material on the outside, but the rest of the wall assembly. It protects the entire...
Right.
Now with especially that kind of a sheathing material, it's replacing plywood. You used to have plywood on the outside of a wall. What do you do for, strength that away?
Well, racking strength in plywood is, of course, very great. But we find that if you're not using the plywood on the exterior, because you're trying to use a product that has a higher R value, you simply put in diagonal bracing to ensure that you get the racking strength that you require. So you might, for example, if you have a 2x6 wall, see a builder putting a 2x4 block in there, letting in a brace, or alternatively there's a steel brace that can be used that just sits into a saw kerf.
Okay, so there are a variety of ways you go about sheathing, but basically the idea here, the basic idea is to get some R value on the outside of the wall where you really had nothing because there was plywood. And then
if we're looking at improving the R value of a single stud wall, we have just finished reviewing what can be done on the exterior of that to beef up the R value.
Okay, and you're also, now as a kind of a bonus over conventional construction, you're making this barrier continuous, and you're also getting a little extra insulation over that plate and everything.
Plate to reduce thermal
Now,
bridging.
what sorts of things can you do to improve the inside of the wall? Do you have more tricks? So you've brought me all this way to look at a couple of 2x2s nailed onto an ordinary wall, right?
A little bit more complicated than that. That chalk line is the first thing that went on this wall, before the insulation or the poly. First you chalk line the walls to set the heights of the straps, then insulate the wall, put the poly on, and when the poly goes down, carpenters who are very accustomed to stapling or nailing on marks simply staple where the strap is going to be. Then when the strap comes across the wall, the staple is hidden, you have no penetrations of the barrier at all.
You like things like that are nice and organized and pre-planned, don't you?
bet.
But what does this get you? What does strapping get you?
What it really does is creates an electrical chase in front of your vapor barrier. So you now have an opportunity for the electrician to run his wires right through into shallow boxes if you're using 2x2s, although you could use 2x3s, And you've got to be very careful with these shallow boxes not to penetrate the vapor barrier. You put a piece of cardboard or a piece of foam behind it.
For the screws that hold the clamps, right?
Right.
See, and something else I notice is you're having to use little strips of wood now because there's no drywall to sandwich that seal.
And the operative word is little. You've got to make sure that you're using something thin enough so that when you install it, you can run the wire past it and the electrician doesn't have to drill.
So we just have these straps running horizontally, and that's the key. Do I guess right that this piece of strap was put in just for that box?
Just for the box. You'll also notice that there's a 2x4 at the bottom of the wall. The purpose of the 2x4 is to nail the baseboard, and that's equally true for kitchen cabinets, for example, where they're on outside walls, or for closet rods. You've got to make sure there's solid backing in the wall.
The electricians must love this, but is it really worth the extra time?
Depending on your operation and depending on the type of house you're doing, it can be the quickest system because you don't have to mess around with a vapor barrier around all the penetrations.
Oh, looks great. You think we can go someplace where the water isn't dripping on me?
Yeah, all right.
Let's flip back.
Here we go.
So we're able to see this is the entire finished wall assembly, isn't it? That's all there is to it.
Going from the outside to the inside, the whole thing. What we've got out here is the insulative sheathing, which is beefing up this single stud wall. We've expanded that to a 2x6 full of R-20 insulation. We then have the air and vapor barrier. We've got the interior strapping with additional insulation in it and the interior finish.
Well, it's kind of impressive, it seems to me, correct me if I'm wrong, but this is all pretty straightforward, the changes that you're making to the single stud wall, aren't they?
It's really just that single stud with no major change except for the alteration of plywood to foam on the outside and the addition of this interior strapping.
Well, now that seems simple, but I want to be careful here. What about the guys who are installing all this stuff, who've already built 1,000 houses conventionally? Does this throw them off the track? Is there a misunderstanding period there or something?
Certainly no problem on the exterior. On the interior, as soon as you start working on the inside of the vapor barrier, you can have some misunderstandings. If you're looking at a circumstance where you do not have the interior strapping, but you're just going through the vapor barrier, you obviously have the problems of sealing all the openings where there are electrical boxes. Alternatively, if you're using the interior strapping, you then have nice access for all the mechanicals and electricals, but you wind up occasionally having to bring guys back at different times during the process, so there's some sequencing difficulties there.
Okay, now, well, you're a small builder, and you're on site, and you've got a guy that's been with you, and you've been doing this for a long time. What about the guy who has these large building sites, you know, these large tracts, and he's got hundreds of guys coming and going? How does he approach the problem of that?
Training is the absolute essence of that. I think that the smaller guys who are there all the time find this kind of alteration a little easier to achieve. And it doesn't mean it can't be done on a larger scale as well. It just has to be really very, very carefully planned for.
It's interesting. It's so straightforward, like I said, and yet you have to worry about those implications to getting it put together. What other kind of wall construction are we going to look at?
Well, we're going to be looking next show at double stud construction, which actually is using this same single stud configuration, only imagine it's split. So we might be talking about two 2x4s that would be spread apart so that we can enhance the R value of the insulation, or the insulation levels, right in the stud wall.
That's pretty interesting. I'm sure it's going to make more sense when I actually get to see it, as always. So join us on the next program of R-2000, The Better Built House.